Hello, hi, good evening, all of you. Today I am going to explain about the combination of capacitors, series combination, and parallel combination of capacitors. Right. So let's get into the video. Right. So combinations are two types: series combination and parallel combination. And the first of all, I am going to explain about the series combination of capacitors. Right. So series combination means the combination of capacitors in which charge is constant and the potential is varies, right? So here I am taking the combination of capacitors, the combination of capacitors in which q means charge is constant and potential is varies, and potential is changes. So q is constant and potential is changes is known as series combination. So here I am taking n capacitors, 1, 2, 3 and so on, n capacitors. So they are connected to a battery like this. So this is the battery. Now here capacitors are C1, C2 and so on, Cn. So with a battery, C1, C2, C3 and so on, Cn with a battery. So here positive, negative. So here in this combination, Q is passing through the each capacitor, Q. So Q is same and the potential is varies. Here the potential is V1, here the potential is V2 and so on, here the potential is Vn. Right? So we know the formula for the capacitance. C is equals to Q by V. This is the expression for capacitance. We know that C is equal to Q by V. Now this entire circuit, this series combination of circuit which is taken as single circuit like this. So single circuit means here the total potential V is divided as V1 plus V2 plus V3 and so on Vn. So this is say equation 1. Now sum of the all potentials are equals to net potential. So for example here I am taking 100. So 100 is divided into the circuit. The sum of the V1, V2, V3 and so on Vn, they must be equals to net potential V. Right? So here this n capacitors are combined to form a single capacitor like this. So here this is the effective capacitance, effective capacitor of all the capacitors. So I am taking here C and here the charge Q and the potential V, right? Now here I am trying to explain about the how potential is divided at V1, V2 and so on Vn. Now first of all I am trying to write down the equation for the potential. Now what is the expression for the potential? So potential V is equals to Q by C. V is equal to Q by C. So here the V. Now here the V is equals to Q by C. So this all the capacitors are taken as the effective capacitance, that is C, and now V is equals to Q by C. Similarly here the potential at the first capacitor, V1 is equals to, at the first capacitor V1 is equals to Q by C1 where Q is constant, and now this is at C1. And now V2 potential at the second capacitor, now this is taken as Q by C2, this is at C2, and now potential at the nth capacitor, so Q by Cn, this is at Cn. Now these four expressions are substituted in equation 1. Q, V, V1, V2, Vn are substituted in equation 1. So all values are substituted in one equation 1, then we get now v is equals to q by c, that is equals to v1 is equal to q by c1 plus v2 is equal to q by c2 plus and so on q by cn. Now here q by c is equals to, here q put it common, now 1 by c1 plus 1 by c2 plus and so on 1 by cn. We know that, right? Now here q and q gets cancelled. Now we have finally 1 by c is equals to 1 by c1 plus 1 by c2 plus and so on 1 by cn. So this is series combination. So therefore now I am taking CS. CS means a series combination of capacitors. So this is the final expression for the capacitance of the series combination of all the capacitors, right? If we take all identical capacitors, now what happens? Identical capacitors, if C1 is equals to C2 is equals to Cn is equals to C, identical, then how can we write that? So Cs is equals to 1 by C plus 1 by C plus and so on 1 by C n, n by C. Now 1 by Cs is equals to n by C. Now Cs is equals to C by n. So this is also another expression for the series combination of capacitors, right? Okay, please make note this, all of you. And the next one is a parallel combination of capacitors. Second one is a parallel combination of capacitors. Parallel combination. So parallel combination means here which is quietly different from the series combination. So now what is the series combination? Q is constant and V is varies, V changes. But here, so charge constant, charge varies, charge Q change, potential V constant. So this is known as parallel combination. So here I am drawing a circuit. Let us consider n capacitors, C1, C2, C3 and so on Cn. So these all capacitors are connected to a battery. Here this is the battery. So the first capacitor C1, capacitance C2 and Cn, nth capacitor, and the potential is V. Now here you can observe here at this junction total charge is divided as Q1 and here Q2 and here Qn and so on, but the potential is constant, the potential is V, and same here the V and here also V. So this combination is known as parallel combination of capacitors. So in this parallel combination of capacitors, now Q is net charge. So net charge Q is changed as Q1, Q2 and so on Qn, right? Now I am writing here, now total charge, net charge Q is equals to Q1 plus Q2 and so on Qn. Say this is equation 1. Now this entire circuit is written as single capacitor like this, effective capacitor like this. So here Q effective, here the charge is Q and the capacitance is C and the potential is V, right? Now here the Q is written as Q is equals to CV, from this circuit. So here this entire capacitors are taken as a single capacitor. Single capacitor means this effective of all the capacitors is given this capacitor, right? Now from this capacitor I am writing Q is equal to CV. And now what is the charge at C1, the first capacitor? Now therefore Q1 is equals to C1V at C1, and similarly Q2. Now what is the Q2? So Q2 is equal to C2V at C2. at C2, and Qn is equals to Cn into V at Cn. Now these all the charge values are substituted in equation 1. Now substitute in 1. Now what we get? Now here Q Cv, Q1 C1V plus Q2 C2V and so on plus CNV. Now here we put it common. Now what we get? C1 plus C2 plus and so on Cn. Now we gets cancelled. Now therefore this C is taken as C effective. That means CP. CP means a parallel combination of capacitors. Cp is equals to C1 plus C2 plus and so on Cn. This is the expression for the parallel combination of capacitors, right? Now if all the capacitors are identical, so that means if C1 is equals to C2 is equals to C and that is equal to C, now Cp effective or parallel combination of all the capacitors is written as C plus and so on C. Now that is equals to N C. This is the N identical capacitors are connected in parallel combination. The effective capacitance Cp is equals to Nc, right? Please make note this, all of you, right? Okay. Parallel plate capacitor, expression for the parallel plate capacitor. This is also important and very easy to learn and very easy to understand, right? I am writing here parallel plate capacitor expression for parallel plate capacitor. Parallel plate capacitor. So parallel plate capacitor means I am considering a parallel plate capacitor. So this is the one of the plate, positive plate, and this is the negative plate of the capacitor. So one plate is positive, another one is negative. Now here the distance between these two plates is D. Now area of the plates is A. Now when Q charge passing through these capacitor plates, V potential is developed and the electric lines are passing through them. Uniform electric field intensity is developed between the plates E. Now but the edges, curved electric fields are developed. Curved electric fields. So this curved electric field is known as curved electric lines, also known as a fringing effect. Fringing effect. So this is known as fringing effect. Now between these two plates, the uniform electric field intensity is developed. Uniform electric field intensity developed. But each plate have some surface charge density. So this plate have surface charge density. This is the positive plate have surface charge density, and this is also negative plate. This is also have some surface charge density. Now what is the expression for the surface charge density? Surface charge density sigma. Now sigma is equal to charge per unit area. This is known as surface charge density. Charge acting per unit area. This is known as surface charge density sigma. Now electric field intensity of the one plate is electric field intensity of the first plate is, this is the electric field intensity for the first plate is E1, that is equals to sigma by epsilon naught. Sigma by epsilon naught. For one plate 2 epsilon naught. Sigma by 2 epsilon naught. And similarly electric field intensity for the second plate. So this is the second plate and this is for the first plate. Now E1 I am writing here. Now E2 is equals to surface charge density by 2 epsilon naught to epsilon naught. Now the net electric field intensity is equal to E1 plus E2, that is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that is equals to sigma by 2 sigma by epsilon naught by 2 sigma by epsilon naught gets cancelled. Then we get sigma by epsilon naught. So ఇట్లా రాసుకుంటాం. రెండింటిని యాడ్ చేస్తే మనకు ఈ వాల్యూ వస్తుంది sigma by epsilon naught. So this is equation 1. Right? And now what is the value of sigma? Sigma is equal to charge per unit area. Now E is equals to, so yeah, so sigma, what is the value of sigma? Sigma is equal to charge per unit area. So say this is equation 1. This is the equation 1. But here the electric field intensity, now relation between E and V. So electric field intensity potential. Now what is the relation? Now E is equals to minus V by D. So the negative is negative potential which is the opposite in direction. Now but I am not considering here the negative, right? Say this is equation 2. Now from 1 and 2 what we get? From equation 1 and equation 2. So therefore we have Q by A epsilon naught is equals to V by D, and Q by V is equals to A epsilon naught by D. Now here Q by V means C, capacitance. C is equals to A epsilon naught by D. This is the expression for parallel plate capacitor. So the Q by V means expression for the capacitance. C is equal to A epsilon naught by D. A means the area of the plates, area between the plates, and now D is the distance between the plates, and epsilon naught permittivity. So epsilon naught is equals to 8.85 into 10 power minus 12, 8.85 into 10 power minus 12 coulomb square per Newton meter square. This is the value for the epsilon naught. Now this is the expression for the parallel plate capacitor. Parallel plate capacitor. Okay, I hope you understand well, right? So please make note this. So if you have any doubt, please comment on the below, right? So please subscribe my channel. My channel is Physics Master. My name is Narsimha. Okay, thank you.